Welcome to EANTC 2021. We are here to do a demonstration of one of the use cases we did together with our partners between Cisco and Juniper, and the test case is called Dynamic Instantiation of SR Policies. My name is Jose Liste from Cisco Systems, and I'm joined by
Rafael Schmidt, Juniper Networks.
All right, so let's go into the details.
Yes.
This test case had two primary objectives. Number one, we wanted to demonstrate the ability of the vendor implementation to automatically or dynamically instantiate an SR policy based on a BGP service route. And second, the ability to automatically steer traffic over an SR policy. So when we talk about dynamically instantiating policies, we talk about intent. And the intent is carried by the BGP service route directly and is encoded using a BGP extended community called the caller extended community. It's a 32-bit number value, and it could signify any intent that the operator wants to express in it. It could signify minimizing delay, as an example, say color blue, or minimizing cost, color orange. And if we look at what happens in the workflow when we instantiate a policy dynamically, we find in the first step, the egress PE will signal a service route that carries a particular color. In this example, color blue. The route is coming from egress router E2. The ingress router E1 receives the route, and it has been pre-configured to automatically associate a particular transport intent to the color blue. In this example, we say minimizing delay. The arrival of the service route with the color blue from node E2 will trigger the ingress router to instantiate a segment routing policy of that color blue with an endpoint of E2 that minimizes the delay. So in the last step, when the traffic arrives on E1, it will be automatically steered for that prefix over the SR policy that was dynamically instantiated. And that is the concept. In this test case at EANTC 2021, Juniper and Cisco put together a segment routing topology using MPLS data plane and ISIS as the IGP. We had two types of services configured between the PEs, layer 3 VPN services as well as layer 2 services using EVPN BPWS. So the objective was, number one, being able to instantiate and steer traffic for an L3 VPN over an SR policy, and likewise for EVPN BPWS. We had a topology multi-vendor between Cisco and Juniper. As you can see in the drawing, there is a router on the top, Cisco PE. There's a router in the middle bottom from Juniper, and the CEs were sending both IP and Ethernet traffic that was being mapped into different services. The blue and the green arrows signify the dynamically instantiated policy. So now let us show you the live demonstration.
So now we are going to begin the demo. First, we'll demonstrate that there is no active session between PE routers in the BGP. Then we demonstrate that there are no LSPs between both routers, and then we'll demonstrate the routing tables of the L3 VPN service, which does not contain the remote routes, and then we will activate the session to show the instantiation of policy. Let's show that there are no LSPs.
I have no neighbor to you.
I have no neighbor to you as well, which is visible. I have no running prefixes. Now I'm going to activate the session.
Likewise, on the Cisco side, there are no policies and there is no prefix being learned on the VPN.
Now we will see that the BGP session is up and running. And from our side, we have received two service prefixes from remote PE. If you look at the details of these prefixes, we can see that they are being resolved by different routing table, which is called .inet0, which shows the dynamic tunnels.
On the Cisco side, we also saw two prefixes being learned now from the Juniper egress PE, and now my VPN table includes those two prefixes. We can see them here on the screen, and they are mapped to color 488. That's the color that we're using in this demonstration.
Yes, and we can see them both also on the Juniper that there is a route color community called 0488, which is attached to the service route, and because of that is being resolved by the LSP, which carries the 488 denotation.
In the Cisco side, the BGP route coming from the Juniper PE is associated with the color 488. We can see the BGP color extended community. And internally, when programming that route, the route is being programmed against the binding seed of the policy for color 88 that takes me to Juniper. Now we should look at the details of the LSPs, Rafael.
Yes, I just displayed the LSP. We can see that the tunnel is up. It's being generated by tunnel dynamic module, and it has a color of 488. It's showing it is going to the Cisco PE and is being resolved in the inet color.0 table.
On the Cisco side, we can see that now we do have one policy. You can see that on the screen for color 488 to the Juniper PE.61. The policy was not there before the service got started, and now we can see the details of that policy. In particular, we take a look at the path. In this case, I'm using a path computation based on the latency, and I have a prefix seed for the Juniper PE that in this case will also minimize the latency.
Likewise, Juniper profile for dynamic instantiation of the policy is based on lowest cost IGP metric. So as you can see, this is only one seed because we are connected directly.
So to conclude, this was the first time demonstration of multiple vendors instantiating segment routing policies on demand based on the arrival of incoming service routes and as well as the automatically steering of the traffic over the SSR policies. We hope you enjoyed the demo. Thank you very much.
Thank you very much.